These days, down here on Earth, it sometimes feels that things are changing far too much and far too quickly. And it's not just Earth. You see, change is a constant in the universe. Stars, planets, even galaxies are always on the move, tugged this way and that by the powerful, ever-present force of gravity. At times, they even collide.
Moonlight.
This may sound alarming, but collisions can actually be beneficial and sometimes beautiful. Come with me now on a journey to places near Earth and beyond the distant reaches of our galaxy to see how cosmic collisions have created our past, affect our present, and continue to shape our future. There used to be a number of theories about how our moon was formed. Not long ago, scientists proposed a new one. Let's travel back in time, 4.5 billion years, to find out what they think happened. What you're seeing is the young Earth. It was a planet still forming, where life had not yet begun. In those early days, our solar system was swarming with large chunks of rock, some as big as planets. A number of them had orbits that brought them close to Earth. This one got a little too close. The collision nearly destroyed the Earth, spraying molten rock out into space. Most of this rock fell back onto our shattered planet. The rest of the rock stayed in orbit. The force of gravity kept it from escaping out into space. As these jagged rocks revolved around Earth, gravity drew them towards one another. They began to collide, fusing together into larger chunks. Within weeks, these chunks combined with others, growing bigger and bigger. And in less than a month, incredible as it may seem, our moon was formed. That's right, it only took 1 month to create our moon. This is the moon today. It's strange to think that the comforting sphere in our night sky was formed by a violent collision, but it was. In 1,000 different ways, this collision made life on Earth possible. The force of it tilted our planet's axis, giving us our seasons, and the moon's gravitational pull causes our tides. Our solar system has settled down a lot since then, so we don't have to worry about another planet colliding with Earth. But other collisions affect us each and every day. Some of the most important ones involve our sun. Don't worry, Earth isn't going to collide with the sun anytime soon. Our orbit is stable, and it should stay that way for billions of years. But all life on the surface of Earth depends on collisions that happen inside the sun. The sun is a star, like the other stars we see in the night sky. It's much closer though, so it looks different, like a gently glowing ball. But there's nothing gentle about the sun. Those dark patches are sunspots. Each of them is about the size of Earth. Sunspots look dark because they're the coolest places on the sun, only about 8,000 degrees Fahrenheit. The rest of the sun is even hotter. The sun's energy, like that of all stars, is created by collisions between tiny particles called protons. Every second, countless numbers of protons collide and fuse within the sun's core, releasing incomprehensible amounts of energy. Most of this energy leaves the sun as light. Some of it leaves the sun's surface in a continuous stream of charged particles known as the solar wind, which blows out into the solar system at almost 1,000,000 miles an hour. Or in less frequent but faster solar storms that blast particles out into space. We're looking at actual images of solar storms taken by a NASA satellite. See that static? That's a solar storm cloud hitting the satellite and overwhelming its imaging device. The solar wind blasts across the planets in the solar system every second of every day. It's so powerful that contact with it would sweep away a large portion of our upper atmosphere, removing much of our water and dramatically altering the development of life on Earth. But fortunately, Earth is protected by an invisible natural shield. What you're seeing is a visualization of Earth's magnetic field. This field arises from Earth's iron core, which makes our planet act like a big magnet, attracting some things and repelling others. Wrapped in this cocoon, Earth is sheltered from the solar wind. But some of the particles make it through this magnetic barrier, eventually reaching the North and South poles. The results are spectacular. Glorious, shimmering curtains of color. This one is the Aurora Borealis, the northern lights. Auroras occur when charged particles from the solar wind and solar storms collide with the upper atmosphere of Earth, causing atmospheric gases to glow. That's the International Space Station, circling the globe in low Earth orbit, about 250 miles up. Not many people have seen the aurora from out in space. The collisions that cause auroras happen between 60 and 300 miles above the surface of the Earth, far above where airplanes fly. And create one of the greatest natural light shows on our planet. But as we've already seen, not all collisions have beautiful and harmless results. One of them was a major factor in an extraordinary event that changed the course of life on Earth. It began out here, where asteroids orbit the sun. Asteroids are pieces of rock and metal left over from the first few million years of our solar system, when the planets were forming. Most of these asteroids orbit within the belt that you're seeing, located between Mars and Jupiter. Some can even be closer. There's only a 1 in a million chance in any given year that a large asteroid will hit Earth. But 65 million years ago, one did.